Hey, my algebra kids, how you doing today? All right, so I'm gonna go over some of these problems with you on the sheet that you are probably getting right now. Whatever you get done, toss it in the bin before you leave. Don't waste time today. So after I'm done going over these, you can work together, you can work by yourself, it doesn't really matter. Just make sure you're working, get it in the bin before you leave. So first one we're gonna go over is number 5. It says 6 square root 147 x to the 4th y z to the 3rd. Remember, we need perfect squares that go into this. So we're going to put all our perfect stuff in the left radical, all the leftovers in the right radical. So if you're running through your perfect squares, numbers that you can square root, and you're looking at 147, it's 49, okay? So 49 times 3 gives you 147. Remember, with the variables, you can have an even exponent for it to be a perfect square. So x to the 4th, that's perfect. No leftovers needed. Y is y to the 1st power, so we can't take any perfect squares out of that, so we put it in the leftover. Z to the 3rd, not even, but remember we can put 2 of them over here, and then the 3rd one goes over there, leftovers. So bring down our 6 times whatever we got here. Square root of 49, 7, right? 7 times 7. Remember, on the exponents, we divide the exponents by 2. So x to the 4th, when you square root it, will be x to the 2nd. If you divide this exponent by 2, z squared, you square root it, just becomes z to the 1st. But we're too cool to write z to the 1st, just write z, okay? And then we got the root 3yz. Last thing to do, multiply the non-square root stuff. 6 times 7, 42. So 42 x squared z root 3yz. There are no more perfect squares in there. There's no denominator to worry about, so you're all done. Cute? Good. We're going to try another one now. Go to number 11. Negative 3 root 21 p to the 3rd times root 28 p to the 3rd. Okay. Let's kind of break this up a little different. Let's get crazy here. ISI. Okay. So negative 3, we'll leave it over there. Now be thinking in your head, let's leave the p to the 3rds off to the side. We got a p to the 3rd and another p to the 3rd. That's all the p's over there. Now look at our other numbers, 21 and 28. Think, is there a number that I know that goes into 21 and 28? That's right, kid over there. I know you said it. It's 7. So 21 is 3 times 7. I'm gonna need a little more room. Time out. Magic. And then 28 is 4 times 7. And then we can use our trickery, huh? So, do you guys remember the square root of 7 times the square root of 7? Yeah, kid over there. That's right, just regular 7, because it would be the square root of 49. We don't do that. We just make it 7. Hey, let's do some more, huh? We got the square root of 4. Oh, that's 2. We got the root 3 there. We'll bring that down. We'll bring down this negative 3 over here. P to the square root of p to the 3rd times the square root of p to the 3rd. Yeah, it's the same thing we just did with 7s, right? Square root of p to the 3rd times square root of p to the 3rd is p to the 3rd. Look at that. Awesome. Way easier. So we look at the stuff out in front and we're like, oh, negative 3 times 2 is 6 times 7 is negative 42. We've got a p to the third. And then our only radical is root 3. Are there any perfect squares left in 3 except for 1? No, there's not. So we're all done. Now, there were other ways you can do that. You can definitely multiply 21 times 28 and get a big old number, but I didn't want to do that. Why? That's right, Colin, because I'm a rebel. What? Ian? That's right, because I'm a savage as well. Okay, well, we'll try another one. Number 19. Oh, no. 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 It's too hard. But remember, even if the radicals are listed separately, you can imagine it as if it was under one gigantic radical. So we can simplify radicals with radicals. What do we know that goes into 15 and 10? Yeah, you. 5, that's right. This class is empty, guys. I'm bonkers. So how many 5s go into 15? 3. How many 5s go into 10? 2. So if we clean up a little bit, which you should do at the end of the day, make sure this room looks nice, otherwise I'm going to be cranky next week. We got root 3 over 2 root 2. And now we're done, right? No, we can't have radicals on the bottom, and I bet Aiden said that already. So, how do we get rid of that radical on the bottom? We multiply it out! So, root 2 on the bottom, you gotta do the same thing on the top. So, on the bottom we got the 2. We've also got this square root of 2 times the square root of 2. Let's use the trickery that we always do. The square root of 2 times the square root of 2 is 2. On the top, the square root of 3 times the square root of 2, they're both radicals. Just multiply them, root 6. Clean it up a little more, 2 times 2 is 4. Are there any perfect squares in 6? Nah, playa. So, remember the 3 things to always look for. No radicals in the denominator, no perfect squares, and then make sure you can't simplify anything outside of the radicals. I think I got one more for you. Oh yeah, number 21, get there. Now, let's look right now. Can we simplify anything outside the radicals? Not yet, but let's get crazy. 5 doesn't matter. It's fine to have 5 there. We can't have the radical, so we multiply it. We can multiply by root 3x on the bottom and root 3x on the top. So we got the 5 down there. And then the square root of 3x times the square root of 3x. That's right, 3x. Because it would be 9x squared that you're square rooting, which is 3x. On the top, we got 2x squared root 3x. Clean it up a little bit, clean it up. 5 times 3x, 15x. We got 2x squared root 3x over here. Check our three things. Do we got a radical in the denominator? No. Do we have any perfect squares in the square roots? 3x? So, look at this stuff on the outside. 2x squared or 15x. Do they have anything in common? That's right, x. So, there's x squared in the numerator. There's just x on the bottom. So how many more are on top? 1. So we can cancel out the x on the bottom. And that would cancel out one of the x's on top. So we would just have 2x root 3x over 15. That's it, players. I believe I'm done with you. Let me just double check though. Oh yeah. I am done with you. Okay, be good, clean up, make it look nice, get it in the bin when you're done.